Welcome to my YouTube channel. My name is Fawaz Aziz. Basically, this in this video, like I'll be creating a simple shell, and I'll be taking you to the process of like creating your own simple shell. So, I think like the next logical question is like, what is a simple shell? Why build a simple shell? Right. So, a shell is like a user interface, right, that helps you interact like with your operating system. I think many of us are already familiar with like what an operating system is. So the popular ones like Windows, Mac OS, and even like Linux, right? So on here, right here, like I have a Windows operating system, right? So if I was to go here to the File Explorer, and I was to, let's say, click on downloads, right? It will give me like a list of files or folders like within this downloads, right? And if I was to click here, details, let me click on a particular file here. Say, yeah, it's going to give me like the path. So right here, this is the path like of the file, like the file location, right? So um yeah, okay, general. Okay, yeah. So this is the path like of the file. So if I can like use my cursor, move my cursor around, click on things and interact like with my operating system and it gives me a particular output, it means that this is like a user interface, and this particular one is a graphical or a graphics user interface. So we have like two modes of like interacting with an operating system: the graphics user interface like this, and a command line user interface. So a command line user interface is basically a word based like user interface, right? So it basically just consists of you passing commands to the operating system, it's interpreting those commands, checking if the command is legitimate or not, checking if it is a valid command, and also like giving you the output you want based on the input that you provide. So if I was to go here now, say on my Windows computer, I go to PowerShell. So PowerShell is basically like an example of like a, a command line interface for the Windows operating system. So this is user right here. If I was to click on like the list of directories within user, then I go to downloads, just like I went to the graphics on the graphics user interface. Yeah, let me say clear. Then I list like the files within my download directory. You can see that like it's still basically like the same thing. It's still basically the same thing, right? So that means you can interact with an operating system through a graphics user interface, and you can interact through like a word-based command line interface. So ls basically means like list files, and if I was to say something like, let's say, cd slash, right, so it means okay, no, maybe this doesn't work on the PowerShell, right, because I'm used to using Linux. But if I was then to change like the path, let's say I designate, let's say, users, user, right, then I was to like go back, if I was to go back here, right, so exactly, this takes me back to the old directory that I was just coming from. So yeah, this is like a Windows version of a shell, but then like I won't be building the shell on PowerShell, right? I'll be using a Linux operating system to build the shell today. So but then if you have been following like this video so far, like why exactly do you need to build a shell? Like what's the significance of like building a shell, and how important is it? Like what can it teach you about programming? So I think if you're a systems programmer or you're a backend developer, it helps you to basically like understand like most of like concepts, because like for you to be able to take on this project, you have to understand some concepts about like operating systems, right? So, and it helps you to be to sharpen like your low level programming skills, because we're using C. I think C is one of like the programming languages that are closest to hardware. So basically, you're in control of your memory allocation. You're in control of most things. You designate most things yourself. So then it also helps like with your systems thinking, and it also helps you to understand how like a command line interface like works internally, or how like a user interface basically like works, irrespective of whether like it's a graphical one or a command line one. So meaning that like if you build a shell with your own specific instructions, and like you list out a bunch of things that you expect the user to do, then you can create it in such a way that like it executes those things based on the input you give. You give your own particular kind of output. So I think that's really cool. Then I think in general, like if you're a systems programmer, a DevOps engineer, or a backend software engineer, it's a great project to have like on your portfolio, right? So now, I would just like to let me show you my objectives for this simple show, because I'm not really doing anything too complex, nothing advanced, nothing flashy, just a simple, direct, step by step analogy, step by step, like writing and analogies of what I think based on my objectives, based on the problems that I'm trying to solve. I would like be writing the program. So okay, objective number one here, right? Write a command line interpreter. So basically, let's see, let me go to my Linux shell right here. So I've opened like a bunch of directories. I've opened two directories here. So if I was to say ls, right? I don't have any files currently in this directory, so it wouldn't show me any files. But if I was to just put in like a random command and I click enter, right, it says command not found. And what we can notice in this sequence right here is every single time uh, the shell gives me a prompt, right? It gives me the name of the computer, it gives me the name of the user, the computer, then the directory that I'm currently in, and it gives me like this particular prompt in front. So it means that like it is something that is a continuous loop, right? It always like wants to get input from you constantly, and based on that input, it gives you a particular output. So I gave it a wrong input here, or I won't say wrong, a non-valid or a command that is not recognized by the shell, and it says what's it called, command not found. So basically, you want to, one of the first things you want to like achieve uh, when you build a shell is you want to be able to show the user right to the screen, right, to the user a particular prompt, right, and you expect to collect input from the user, right. So that means like you have to program for, you have to collect input from the command line. So then, based on those inputs, you start handling things for what you want from the user, and what you are going to return to the user, right? So the command line handles arguments. So okay, basically, when you pass a command, right? You let's see. Let me go back to the previous directory here. I have a bunch of shells right here. So when you pass a command, let's say like list now, it's basically like one command on its own. But then you can do something like this, lsl, right? So this basically means like long listing, right? So it shows like the user, it shows the date of creation, it shows the time of creation. It shows like the read and write, or would I say the permissions of the file, basically. So This is an example. The L right here, the L flag right here is an example of what arguments to a command. So basically, an argument to a command instructs the command on what to do, right? It instructs the command on what to do and how to behave. So that's what we are going to be taking in when that's one of the things that we're going to be factoring in when building our shell. Then handling path. So handling path is like determining whether a command is valid or not. So we are going to create our own internal system or function that determines whether like the command that a user passes in is a correct command or not to execute, right? So um, then we are going to implement exit, we are going to implement env, and we're going to implement a getline function. So basically, all of this, right? So if I was to say, um, let's say I say this, if I was to say env right here, so it gives me a list of environment variables, basically the name of the computer, the present working directory, the log name, the home, and all sorts of data. And it also gives me what's it called, the path of the computer. All right, so if I was to clear this, then I was to say something like let me say what was the other one, right? 'Cause I don't want to exit the program, but then if I was to say exits, right, it exits what's it called, it exits the shell. So we want to be able to execute like all of these commands. So implement setenv, implement unsetenv, and like the built-in command change directory. So basically, like if we go to our PowerShell here, every time we do something like this cd, then let's say we click on, no, we do something like downloads, right? So this is an example of a command. Cd is the command, and downloads is the argument to the command, right? So if we were to list this, it shows um, the list of files like within that directory, right? So we are going to program for that. So that's basically like the 9 simple objectives that I want to go after in my simple shell, like in my implementation of a simple shell. So a bunch of concepts. So right here, these are some concepts like to be familiar with. Before you could like say you want to create a simple shell or a shell basically, and like they are mostly like operating system concepts. So process management. So basically, like I think I'll have to define like what a process is right here. So a process is like of an instance of an executing program. So basically the difference between what a process is and like what a program is that like a process is an executing program, while like a program, right, is a set of instructions that you've put into the disk of like a computer basically. So that means like the program itself is passive, right? But then like the process is like the active execution of the process is the active execution of what like the program is. So you could understand the difference between a process and a program by like, okay, say I do something like this, say if I, okay, this is an empty directory, right? Say I say if I shell.c and I start to say, okay, let's say I insert, say I include stdio, I include um, ini std. Okay, so let's say I include std, alright, and I come here, let's say I say it's main, right? Then I create what's it called, a string, and I say John, right? Then I say printf, let's say next line, boom, str, right? Say 0. It was to demonstrate a process ID, right? Say, okay, I already included uni so say something like this, and use get PID, right? This is a function, right? So we can say something like this. My name is, then we can do something like my PID is. So I think percent U is the format specifier for PID. So we can do something like this. Right. So it was come out here and basically compile the program. Right. So now I think we have like the executable file. So if we were to do something like this, shell, right? It says my PID, my name is John, my PID is 1000 or 1740, right? So if I was to run the program again, it's going to be with a different PID. If I was going to run the program again, it's going to be with a different PID. So basically, each time you are running a program, it is allocating a different process ID to that particular program, right? Um, so each one of them like is a process on its own. So if we were to do something like this now, say um, let's do something like this. Say get say PID say PPID get PPID. Right. So can do something like my parent ID is, so let's move this away. So percent U. Right. So next line. So we have three format specifiers here for string, for PID, and for PPID. So let's compile this. Now we have shell. Alright, so my name is John, my PPID is 1751. My parent ID is 1272. So if I was to run it again, you have this. If I was to run it again, have this. If I was to run it again, you have this. So basically, what it's showing is that like there's only one parent ID, right? That is home to all of these process IDs. So and also basically what's it called? This shell right here and this executable file and this C file right here are programs, right? So the moment like you let's say like you are executing a program now, say something like shell, right? In this process, right, a process ID is created for this program. It has its own stack and heap, and it has its own memory. So basically, like that's like the difference between a program and a process. So, and we have a concept known as process ID. So basically, it's a unique address for a process for you to be able to manipulate that particular process. Let's say you want to create a what's it called, a child process, or you want to kill it, you want to what's it called, terminate a process to create another one. You have to use the PID, that's the process ID. So now basically there are different types of processes like there's the foreground process, there's the background process, there's the parent process, and there's the child process. So the process is the one in which like input from the user is required, like there has to be like some form of interaction. Then the background process is the one in which like user input like is not required. So but then there's a relationship between a parent a process and a child process. So a parent process is used to create a child process. So think about it like this. Let's say you're a boss, or you have a boss that like gets an employee, right? And he wants that employee to do the task, but he wants the employee to do the task the exact same way he would have. So he transfers his knowledge, his exact skills, and literally like makes a copy of himself in the employee. So that's what like the parents ID does when it creates what's it called, a child process. That's what the parent process does when it creates a child process. So basically, it's like a system of delegation, right? Where like you have a parent process that has its own memory and system resources, but then like it creates a child process which it delegates a task to. So now the process of that you can use, so you use this system call known as fork, right? So fork creates like the child process. Execv like runs the instructions, the commands with the command arguments and the environment variable. Then wait PID helps to terminate the process once the task is done. So basically, why this is needed is because um, the a shell is something that is theoretically thought of as something that can run infinitely, right? So you need to be able to delegate a task to a child process. So once the child process is done, you terminate the child process, you return back to the parent process, then you continue over and over and over again. So if I was to go to my shell and I did something like this, ls, then long ls, right? And I kept doing this, right? It would continue infinitely. It will continue infinitely because there's a process of a parent to a child process like relationship where the parent keeps like delegating to the child, and when the child process is done it terminates and it goes back to the beginning of the program. So it's done again and again and again and again like that. So um that's a very very interesting concept, right? So basically file system management, so this like involves the creation, storage and modification and also deletion of files and directories or folders. So this is very, very important in terms of like naming a file, retrieving a file, moving a file, creating a file, and also like keeping them keeping them in an order in which like they are easily retrievable. So this is a very important concept to understand when trying to build like a shell. So and also memory management. So the thing is, going back to the initial thing I said about like a shell being able to run infinitely, right? So it's a continuous program, like using a Linux, a Linux operating system or any operating system for that matter, is meant to, be able to communicate with the user infinitely, right? So, and if you are going to have a program that communicates with a user infinitely, you don't want a system whereby like you are allocating memory for variables created and you're not freeing those memory because as much as we know, every computer like that is or every personal computer has like a capped memory size, right? So and as you run your program, as you allocate memory to variables, you have to also deallocate. You have to also free up those memories so that like it can, so that the program can keep running, right? So that like there's space for you to keep running your program over and over and over again. So because the issue is, if you create a program, right? If you create a program where like you are not efficiently like allocating and deallocating memory or freeing up memory, what's going to happen is you are going to get to a point where you've allocated so much memory that there's no more memory to allocate anymore. So you can't run out of you can't run your program anymore. So the concept of using malloc and free is very very important. So basically in C, if you are familiar with the programming language, like you depending on the size of the bytes of the data type, maybe it's an integer, maybe it's maybe it's a character, a string. That's it depends on the amount of characters in that string, right? So you are able to allocate memory, and also like if it's a struct, yeah, you can also determine the size of your struct and allocate memory to your struct, right? So memory allocation and freeing up memory is a very important concept in being able to like build your own shell yourself. So input and output management. Okay, so this is also very important because like remember like you're taking in inputs, right? In terms of like you regard them as commands, right? And you're also giving outputs. So this is done with a whole lot of like functions. You can use getline, and also you can also read from files. Use like open, right? So open, when you use open, you create a file descriptor, which you can use to like read. You can read that particular file, and you can also like write into standard output. So basically, you can take information from standard input and you can write into standard output. So I think if I'm correct, the file in what was it called, the file descriptor table, we have zero for input, we have one for output, and we have two for error, right? So I think for standard error basically. So I think like that's like the concept of basically input and output management is that like how can you get input from the user, how do you manipulate that input, and at the end of the day, like when you finish like running your command, like what calls do you use to like give outputs to the user. Okay, so it's basically simple, and I think like um Unix APIs that like allow you in C to be able to call on your device, right? So basically, if I type into my keyboard, right, I could get like that input and what's it called, save it in a particular variable, and I could do whatever I want like with that particular data, and I could give my output back to the user using write. So these are very important system calls to understand. Then also like the built-in commands. Basically, you have something like env, which is a very very powerful built-in command. So if I was to do something like env here now, okay, so you can see like it gives like a whole host of information. So it's basically a set of variables and settings that like basically influence your shell and how you run your program. So it creates like time specific data, and it also helps you to, let's say like you want to run something like a change of directory, like it keeps uh very sensitive for very important information like your present working directory, like your home directory, right? Like your old working directory, like the path. So an environment variable like the path can also like be used to basically determine whether a particular command exists or not. So basically, the environment variable is like a default list of like information that like helps you and shapes and influences how your shell operates and how like your program operates. So it's a very very important concept, right? So then uh, Setenv, that is like you could add more environment variables, and Unsetenv, that means you could remove what's it called, environment variables. So basically, if you come here, say env, right? Each of these right here, this pwd, pulse server, path, nvm underscore cd, user, right? Info path, right? Language, right? Home, pwd, and so on. Name of the computer, right? They are all environment variables. They are all environment variables, and you can use getenv. That's also a built-in function to be able to get like each kind of like environment variable based on like what you are trying to do. So it's so like mind blowing, right? So then also basically like I said, if you use cd is a command that shell recognizes, right? And the supporting what's it called, arguments to it, the arguments to the command, right? Say if I say something like now, if I come here, if I clear this now and I say something like, let me make a new directory, let me say my directory, right? Let me say something like my directory, right? If I list it, my directory appears. Then I say something like cd, or let me say print environment, right? Print env, right? So it gives me my environment. So remember, like we have an old working directory which is simple shell, right? And we have a current that is like pwd, parent present working directory here, right? Once I do this now, I clear, and I'm about to change my directory to uh, my change the directory to my directory, right? Um, the environment variable also changes, right? So if I was to say print env now, you can see like the old working directory becomes the previous one, then the current one like becomes the one that I just changed into. So basically, keeping a log of your previous actions and knowing uh, how to retrace back into like sets of like tasks, sets of things that you've done before. Basically, like it's so powerful. It influences how like the shell behaves. So if I was to clear this and say cd, um, yeah, so basically that uses like the power of like the environment variable to run the program. And let me remove this because I'm not going to use this. Let me remove the directory. I just wanted to use it to show something. So all right, that's gone. Boom. So back to this, right? So and also like exit is a exit is a built-in function, very powerful uh function, right? So now a lot of like important built-in functions in many of like the C standard libraries like stdio. You have printf under there, stdlib. You have a lot of data types that are like predefined under string.h. Like you have str which allows you to tokenize a string into a list of like strings basically, and do like a bunch of cool stuff that we're going to get into. So, and you need to understand core concepts like strings, pointers, arrays, and memory allocation. So, basically, having like core foundation of like C programming concepts, like you need that to be able to like go into um, uh, building your own shell. So, and for me personally, like learning to do these things, I think it's always like good to go to the source, right? So, I created a list of um, basically a system calls that you could check um, the manual for, right? So I love Linux so much in the sense that like most of like the functions that are available, right, and most of like the system calls, like you could actually check for their description. You could check um how they work, the examples of their use cases, and the pitfalls, and what the return type is, what the function type is, stuff like that. So if we were to do something like let's say man str talk, right? So let's say man str talk. Yeah. Right, good. So it basically like gives a rundown of like what uh the function does, right? So extract token from strings, boom. Synopsis. Okay, it is in this particular library, this header file. So yeah, this is the prototype. So basically you take a string, right? And you define your delimiter. So basically, what the delimiter is what you are trying to tokenize, like the string by what you are trying to separate the string by. Let's say you have a full string and like you have comma there, and you are trying to separate each word before or after a comma, right? So basically, you could like use the comma as like your delimiter. So the description of like the function is there, the return value of the function is there, the attribute of the function is there, the bugs are there, and like the example, the use case is there. So it's so interesting, right? So we can move on to like the next one. Let me see which one is very interesting here. I would say something like let's say man3 getenv, right? So let's say, all right, so basically it shows the header to include, or the library to include, to be able to use this particular function. It shows the arguments needed to be passed to like the function. So basically, it's a variable. You need to specify the kind of variable that you're looking for, right? So basically, getEnv function searches the environment list to find the environment variable name and returns a pointer to the corresponding value string. So meaning what it does is this is that like let's exit this now. Whenever you go to env, right, what getEnv does is that like you have to specify whether you're looking for a user, whether you're looking for the path, whether you're looking for the old working directory, right? So if you specify that, to give you this value, boom, let's say it's old working directory. If you specify path, right, as the name of the environment variable you're looking for, right, it will give you the whole path, right? So it's so interesting, and it's a very powerful function basically. So let's clear this. And that's mostly like if you have like a good grasp of all these things, then you can continue like into the video, follow along, or like do it on your own too. So yeah, let's get started. Let's open this up. All right, so let's click on insert here. Basically zoom this in so you could see my screen properly. All right, this is in insert mode. Zoom out, then include uni std, include. All right, so these are the header files we're using in this shell program, in this shell project. So uni std, this is the header file, which is a POSIX API. So the POSIX API is basically for portability of programs created on Unix-like systems. That is like if you use the POSIX API to create your programs on a Unix-like system, then it is portable across other Unix-like systems, and it gives you access to a bunch of system calls and functions which I'll be using in this program. It helps with process management, file input and output management, helps with file creation and deletion, also helps with making directories, changing directories, and also basically deleting directories. So it's a very powerful API, and I'll also be using stdio, which also helps with file input and output management. But majorly, what I'll be using here is printf, which basically, based on your format specifier, helps to basically output formatted, or basically gives formatted output to the user. So I think it's a variadic function which can have like an endless list of format specifiers with according to the amount of arguments you want to pass to printf. So basically, so far as it's a valid variable and you have your format specifier, you could use printf to output data to the user. So stdlib is also a standard library that helps with memory allocation and deallocation. So basically, when you allocate memory for, let's say, you create a string with maybe a pointer, a double pointer. Whenever you allocate memory after using that particular memory in the program, you need to also deallocate it. So then I'll be using string.h, which helps to um, which basically gives you a whole host of like functions like strtoc here, um, strtoc, right? So using strtoc basically helps you to separate your string into separate your strings by delimiters. So take for instance now, let's say this is a whole string, right? This is one string. You could convert it into two strings by using space as as a delimiter, right? Or let's say this is one string like this. You can also like separate these three things here, these three words, by by using a space delimiter. So basically, and also like it helps with determining the length of a string using strlen. Also like helps determining whether two strings are the same by using strcmp. The values of the strings are the same. Then also system types. Basically, this helps you to be able to define a child process. Then wait, which provides you with the wait PID function and the wait function. It helps you to be able to properly terminate a child process. So I'll go here. The first thing I'll do is basically say extend char environment. All right. So um this like provides you with your environment variable, which is included in this header file here. So if I was to do something like this, all right, so say man, let me reduce the size, say man environment. All right, so this is a Linux programmer's manual for what environ does. So this is the synopsis, which I've defined already. Now, the description is that the variable environment points to an array of pointers to strings called environment. The last pointer in this array has the value null. Okay, so it's been defined in UniSTD. Okay, so basically gives you a list of environment variables like home, path, PWD, shell, uh, and all sorts of things. So, um, yeah, so this is the description of that. So, if I was to zoom out back, let's go to shell. All right, so let's do something like this. All right, so there are a bunch of variables I'll be using in this shell program. So yes, but it will all make sense once we get started. Um, mm, okay. Say let's say wow, true. All right, so this helps you to be able to keep like a continuous loop. So when you say something is wow true, that is like it is always true, right? Except you give it a condition to exit this loop. So yeah, let's do something like this. Then do something like this. So basically, this is a signed integer for reading the input from the user. So we are going to be using the getline function, and it can return -1 upon error. So we want it to be signed so that like it could account for that particular value. So put this at 0. Then within this, let's define a variable line, assign it to null, right. So this is a system call basically to std out and say what should we. Okay, so basically this we can prompt the user with this a dollar sign and space. So because it's two characters, we put it here. So um, then we can say okay, let me say uh, let's say something like read equals to getline. Let's say ampersand line ampersand len, um, also std in, right? So basically this function helps us to get input from the user, stores the inputs into this variable defined here, and stores the length of the inputs into this variable defined here. So now we were to do something like this. So do something like this. Um, if n read equals -1, okay, that is for an error scenario. I want to expand this a little bit. Alright, so alright, alright, so um basically free the line, right? Um and continue. Oh no, break the program. So basically what this is you prompt the user, you get input from the user, and if it gets to a end of file that is condition, this basically triggers the end of this right here. Triggers a, let's say the end of file condition is triggered. This helps you to break out of this while loop right here. So we're going to do something like this. Say now let's do something like this because as much as possible we don't want any situation where we are messing with the input, right? So use strd up to copy uh, to copy its own version, its own value of what the line is. So basically do something like this. Then say if the input is null, um, free line, and basically continue the program. Continue the program. Um, so then let's give a condition. Say because usually from input, right? The last line of the input is always like there's always a next line. So say the number of characters read -1, right? That is the last character. Let's say if the number of characters read -1, that is the last one, is equals to the next line, equals to next line. Then say um, so basically I'm not terminating the string with this particular code. So do something like this. If we do something like this, um, then we can say, okay, let's stop here and test the code. All right, so all right, let's see how this works. So I'll compile. All right, so basically it prompts me with a dollar sign and space. So yeah, so this is a continuous loop because it's meeting the while condition, right? So as long as it's collecting inputs and I've not triggered any condition to be able to break out of the loop, it will continue endlessly. It will continue endlessly. Or I can exit the loop using Control D to trigger a end of file condition. So right, yeah, so exactly. It's going to exit the program. Then I also like to do something, and I think should be able to just before in case you trigger because there's no next line, right? So should trigger on the next line. Um, so basically next line um, one, right? So yeah, we have that. Then the second thing I would like to do is like I would like to put um the list of user inputs, right? The list of user inputs. I would like to tokenize it into um, an array like of integers, right? So you can have like basically a string is like an array of characters, right? But then you can also have like an array of strings. So that's like a double pointer. So let me do something like this. Define a macro. Say okay. Um, do something. Token size. Say 1024 basically. So now I can do something like this. So here's a double pointer with token size as the size of the amount of tokens, maximum amount of tokens you want. So you can also say let's, let's say int I equals to 0, right? Um, then you can define so you can tokenize the inputs, right? You can tokenize this input copy, right? Um, which is just one string. So since we've not terminated it, like it's just one string inside this input copy here. So we could do something like this. Str uh, so this is the string we would like to tokenize. Then we can use our delimiter. So basically the delimiter I would like to use and which is commonly used is the space bar and a tab. Right. So then we say something like while the token is not null. Uh, okay. So tokens now this helps to increment through the token. So on the very first use, right, I is equals to 0, that is tokens. Since we have like an array of 1024 tokens, right? So um the first index, which is 0, right, assign it this first token that is uh separated by either space or um by tab, right? So say token. So that means we have an array. We have an array of strings. So this is a string, right? And this is an array of strings, right? So can do something like this. Then say tokenize again. Continue tokenizing, right? So str token and do something like this. Use the same delimiter. Um, then okay. So this condition is going to continue. Uh, okay. Let me try. All right? So this condition is going to continue as long as token is not equals to null. So on the last one, that is the last index, basically after while the token is, because this now executes until the token is not null, right? So on the last one, which is null, then you can now say yeah, tokens I is equals to null. So basically, that means like each input, which is separated by a space or by tab, is going to be tokenized and is going to be put into an array of strings. All right, so and that makes a lot of sense. So let's keep this here like this. So now what it means is that whenever we want to start acting on our inputs or we want to start basically using a user's input as a command or whatever is going to be from this array of strings, right? So it has helped us be able to, okay, say, take, in case like the input is a long list of strings, right? We want to be able to separate it and say, okay, this is this is the because the way execv works is this. The way execv works is this, right? It has a command, then it also has arguments to commands. So we were to do this. Yeah. So we come here. Um, let's go up. All right. So one of the first objectives is write a command line interpreter. Right. Okay. We already have that. We prompt and we take input from the user. Then it says handle command line arguments. So basically, what a command line interpreter does is basically takes input from the user, determines whether it is a command or not, and executes that command. So basically, we want to write a, so the necessary things to be able to write a command line interpreter is to use fork, execv, and wait pid. So basically, what fork does is it's creates the child process. Execv basically executes the command, and wait PID kills the child process or terminates, make sure the child process is terminated before moving on. Right. Um, so we'll be checking fork, execv, and wait. So let's see what this is all about here. So let me reduce the size here so you could see. So man to fork. All right. So um, right. So creates a child process. Um, insist. Okay, it is included in system types, included in UniSTD. So basically, helps to this is the type. This is what to call, right, when you want to create a child process. In description, create a child process by duplicating the process. The name is referred to as child. Um, has its own exact duplicate of parent process, blah blah blah. You could read this on your own. Return value on success, the PID of the child process is returned in the parent, and zero returned in the child. On failure, -1 is returned in the parent. So yeah, so now if we go about this right here, then and we do something like this. So let's say PIDT. We already defined PIDT, right? So let's say PID is equals to fork, right? So called function. If we go up here, okay, we haven't defined PIDT, so let's say PID, right? So we haven't defined PID, right? So now it says on execution, right? It returns a zero if it is successful, and it returns -1 if unsuccessful. So do something like this. Basically, print an error. message saying how to create child process. So um, can do something like this: free line, free line, um, free input copy, and also free token, basically. So then we can continue to the beginning of the program. The PID is equals to 0 to do something like so. That means it is successful, right? Um, let's say now. So basically, if you're able to successfully create PID, you could also check for this. So execv. So this is where our tokenization is important, right? So we understand that let's say the first index of the tokens, right, separated by space or by tab, right, is the argument to is basically the command, right? Then the subsequent things after the first token are the arguments to the command. So if we were to come here and check, read the manual for execv, right? So let's see what it says, right? Um, so basically the synopsis. Included in what Unix. So the path name, the command, then the arguments to the command, then the environment variable. So execv executes the program referred to by the path name, right? This causes the program that is currently being run by the calling process to be replaced with a new program. Uh-huh. With a newly initialized stack, heap, and data segments. Path name must either be a binary executable or a script starting with a line of the form. That is, it must be a recognized command. So basically, in your path, if you do something like ls, which is like list the files in a list, like the directories and files in a particular directory, right? It is an executable. It is an executable within path, right? So it must. So you must check. You must. That means you must write a command to determine whether like your you must write a function to determine whether your command is an executable or not, and it is found within the path. So for details of later case, see interpreter script. Boom, boom. So I'm trying to look for the use case. Yeah, errors. Okay, example of usage. Um, let me see. All right, good. So you can see in this particular scenario here, um, this like is an array of like strings, right? So now this one here, okay, where is okay, this one is also an array of strings, right? So but then you have a situation where like you are using execv, right? So and it says pass only what the second argument, that is like if you are familiar with this basically is like the inputs gotten um from your program, right? So this is the second input, pass it as a command, then new arg, that is all of this, right, are arguments to the command, the arguments to the command. Then this is the environment variable. I'm not sure if they define their okay. So the environment variable is null. So basically, it executes and returns 0, right? And upon failure, it returns -1. So yeah, this is an example of the use case. So let's go zoom this out. Um, let's do something like this. Boom. So say tokens 0. All right. So um, then you say tokens. That is the very first command. Then the other arguments to the command, then then you say environ, right? So that's the environment variable which we define at the top there. So um, if what's the -1, print an error, say something like command not found, basically, boom. All right, so um, so now else with PID, right? So then pass the PID, then say status, say something like this, 0. Um, so basically, what we have here is, let's say, um, we have say free line, free input copy, also free token. I'm not sure if we have any other thing to justify. Alright, so let's clear the training spaces. Um, alright, so from there. Alright, so let's execute this. Let's compile and execute this. So, okay. Um, make center. Let me use this. Okay. Um, okay. Okay. Alright. Alright. Let's do this. I think that's first correct. It says, oh, okay. Yeah, this is the mistake here. Tokens. Alright, so I think this should clear up some of the errors. So let's let's compile this again. Alright, so it says expected const void, but argument is of type int. Alright, let's do something like this. Boom, boom, boom. Okay, I think I defined it wrong. Um, Alright, yes. I think they should clear it up. Um, and boom. Yeah. So the code is running now. Clear. So shell. Alright, so it prompts us. It prompts us, right? So if I was to do something like this, in ls, right? Alright, so yeah, it will list the files in my directory. If I was to do something like this, in ls L, right? This means this argument here means long listing. But now, let's say let's exit. All right, so if you were to run this program now, um, and like let's say we do something like this, let's say we don't give it any input, right? It would pass to return an error because basically there's no input to execv, and execv requires um what's it called, a string to be like the argument. So um to be able to fix up for this, and also if you do something like this, you also see that like it returns an error because the path uh of the executable, this is meant to be an executable, right? um execv does not recognize it. So let's exit the program and do something like this. So we were to come here, let's say after we define our tokens, let's, so we could do something like this. So if tokens 0, right, that's if the first argument is null, right? So do something like this. Free line, free input copy, right? Free token, and what's continue the program. So continue means go to the beginning of the program. So rather than it's being passed to execv, it would go back to the beginning of the program if nothing is passed to the shell. So we have a situation, compile again, we have a situation like this, then we can do this. So you can see that it works, right? And it's not throwing back an error. So we can exit this right here, then come here. But if we were to run this, right, and say ls, it still returns it still returns an error, right? This is because like the path or the directory in which the executable file is found um is not being presented to execv. So execv does not recognize it as a command, right? So let's exit this program. We could do something like this. So basically, we have to create a we have to create somewhat of a way to be able to determine whether or not something is, whether or not like an input is a valid command, and we also have to be able to find where it is in the path and pass it to execv. So, but before that, I would like to do an example of something here. So, for instance, now, we are passing, right? We are passing a what's it called? A command with arguments, right? So, if we were to do something like this to this program, um, say something like this, long listing, it works, right? But then we were to do something like this, it doesn't work, right? So, what is happening is that like because we've tokenized the input, right, it can pass arguments to command. But if we were to say, let me say, uh let's do something like this, say, so let's say change this, right, to args, and do something like this. Let's clear so we can see properly. So to do something like this, shell. So normally if we run this now, it works. But if we were to run this, that's like the long listing, right? It doesn't work because it doesn't recognize the arguments to the command. So that's like the importance of what tokenizing like your input and making them like um an array of strings basically. So I'm gonna change this back to tokens. So we come and remove this, right? So if we were to come here, we could determine the path of a command, and if the command is a valid command. right? So we do something like this. Say find command because it's going to be just a string, right? So say command, right? Then you say if command is null, return null, right? That is if there's no command there, right? So you can also say something like this. So basically check um, the first index of the command to check if it starts with a slash, right? If it starts with a slash, then it's probably like a path, right? So you could pass it like that, but then you could also do something like this, say dot, right? Then say access, check the command, check if the command is an executable, right? So that's what X, if it has executable permissions, right? So then we return a copy of the command, right? All right. So why is it like this, right? So let's say we come here and we do. Let me reduce the size of this, right? So let's say we say env, right? If we were to check what's it called, the path here, we'll see that each directory starts like with a slash, right? Or starts with a dot slash, or starts with a dot rather, or a dot slash. So you could check if it's like a valid path or not. So basically that's like the point of checking for a slash or a dot, right? So come here, let's zoom this out. Right, let's continue with our find command function. So okay, so basically say something like path, right? So we want to get like a particular path. So we want to get the path, right? So it's capital, as you've seen from like environment. So we say as because we don't want to what's it called? We don't want to change the path directly. So we say something like path copy, right? So because we are going to be tokenizing the path, right? So we don't want it to affect the path directly. So we make a copy of the path, right? Then we check if it has been defined, right? If not, if not, we return a null value. We return a null. All right, so that makes sense. Then we can do something like what's it called, like directory, right? So you can use str to tokenize. So we're tokenizing the path, right? We're using the delimiter colon, right? So the reason why we're using the delimiter colon is this: if you go back, let's we say print env, right? Each directory or each directory like in the path is separated by a colon, right? So we want to be able to separate them by colons to check if our executable file is within that particular directory, right? So clear this, go here. So the first token I insert, zoom this out. So say while dir is not equals to null. So basically we can also like determine the length of the directory using strlen. We can determine the length of the command using strlen. Then we can also account for the extra slash and null variable that we'll be adding to uh, um, the path. right? So say plus two, say plus two, right? So then you can say something like full path. Okay, so you can say full path is equals to what is assigned malloc len. Alright, so the reason why you can say malloc len like this is because we know that a character is 1 byte, so we don't need to check like the size of a byte that then multiply it by the number of bytes that we want. So since we've gotten like the length of the directory and like the length of the command, and we know like the length of the full path, right? So um, we can just allocate it like this. Then if we say if this is not defined, right? If it is null, then free path copy and return a null one. Alright, so then we can use smprintf so to take all the values or to take all the strings inside of this directory and inside of this command to put it in this variable, right? So say full path, then we basically specify the length, then we use the format specifier, then a slash, then we use the format specifier, then say something like the AR command, boom. So then we check, okay, if access, right, full path, right, this is need capital, okay, boom. So it is a path, then basically free path copy, right, and what return full path basically. Then if it isn't, so we can do something like this for every single time where the full path is not an executable, right? So then we say free full path, right? Then we say tokenize again, so dir is equals to str token, and use the same delimiter. So you have a situation like this, boom, right? So then also like if all fails, right, if it falls through everything, you want to basically free the path copy, then and also return null. Okay, so none of the above works, right? So zoom this in a little bit to see like the full picture. Alright, so find command. Okay, so if our command is null, return null. If it starts with a slash or a dot, check if the command is an executable. If it is, return a copy of the command, right? Also get path, right? Make a copy of path. If the copy is null, return null. Tokenize the path copy. Um, Also determine like whether it is null. So while it is not null, um, determine the length of the directory and the command and allocate memory to it to full path, right? So now if the full path is null, free the path copy, return null. But then if not, continue with the program and um, print the values of directory and command into this full path here, right? So check if the full path is an executable. If it is an executable, free the path copy and return full path. But not all of the above fails, free the full path and tokenize again onto the next one, and use the same delimiter, right? So, but if all of this also fails, free the path copy and return null. So basically, let's zoom this, come here, I'll come down here, say, all right, boom. All right, so say something like, let's say CMD path, right? Let's say command path, basically. So find command. So then pass like the pass the first arguments to it, right? So I'll come here. Let's prototype our function so it can be used like in other. So if we, in case we create like an header file, I'm not creating an header file for this particular program. I just want to run it all in one file. All right, so come here. Right, so we, instead of using token zero now, we start using CMD path. Right, so CMD path right now. All right, good. So if we're to do this, I hope it doesn't return any errors. Let's see how it goes. Boom. All right, it says okay. There was a spelling error there. And which other error again? There was okay, some spelling errors. All right, good. Let me go here. Mm, all right. So this was an error. Remove insert. Remove n. Put the n here. Then this was an error as well. So it's meant to be tokens rather than token. So boom, compile. It works, right? So boom. Let's try let's try the shell, right? So if we do this here now, it works unlike before. And if we were to do this L, it works perfectly. And if we were to do things like commands like mkdir, um, um, let's say what directory? Let's say new directory, right? This is the command to create a directory, right? If we were to list, it works. And if we were to say rm remove new directory, right? Let me see. Okay, rmr, right? Because it's a directory, remove directory. Yeah, it works. So clear also works. So let's exit the command. I'll come here and let me show you the difference, right? So let's do something like this. Let's comment out this part of the code. Let's comment out this part of the code. Then go up and comment out this function, right? Let's comment out this function. Yeah, come here and also comment it out here. Boom. Then if we come back here and wait to say, okay, let's use let's use the previous method, right? Tokens. That's the first input. All right. So if we're to run this now, ls doesn't work. Ls doesn't work. Cp mkdir um, um, doesn't work. So basically, what like a command that checks like if a particular command like is an executable and determines like the path where it does is it finds the path, it searches for it in all of the directories within your path, right, and returns like the executable file. The executables files path to execv so that it could execute, right? So also, what other stuff did we do? Where so say ls also doesn't work. So let's exit the code. All right. So all right. So let's go and uncomment this. All right. So let's uncomment this. Let's yeah change it back to the way it was before. So let's uncomment this. Go down. Let's uncomment this and this as well. Right. So all right. So let's come here and basically use CMD path. Right. So I think everything should be working fine now. Boom. All right. Cool. So basically I think like this satisfies the objective of writing a command line interpreter. So basically taking inputs, perfect tokenizing those inputs into like an array of like inputs so that like you can pass them as arguments. Then also taking like the very first input as a command, and also like checking like for the path of the command, that is this objective here, handle path, right? So then I think the next objective is to exit. Okay, so use like the exit built-in, right? And also build like your own getline function, handle arguments for built-in exit, right? So so you can use different exit types, right? So people exit with different codes. Then the next is setenv, unsetenv, then change directory. So if we were to come here, right, let's say we do something like this, say let's say we run our shell, let's see if it works normally. It doesn't work, right? It doesn't recognize exit yet. So all that one doesn't. So let's say let's pass env to it. All right. So okay, I think it recognizes env already. But then like let's clear. All right. So expand this. I think it recognizes env, but then like the env it recognizes could also like return like an error, right? So let me check if it's the kind of env that we're looking for. All right. So let me see. Uh, so um, let's see if it recognizes CD, right? And Setenv and Unsetenv. So let me put this CD command not found. Okay. Um, let's say Setenv John or okay, cool. So it basically shows that like those things have not like been accounted for, right? So we are going to build them into our shell. All right. So boom. All right. So what's the first? What's the first? Okay. Implement an exit, right? Implement the exit built-in that exits like the shell. Okay, cool. All right. So and also take account for like the code. All right. So let's say we can do something like this. Um, we can do something like if str cmp. No, we can do something like okay. Um, mhm, is exit. Right. So okay. So we can check like we can check if the first we can check if the first input like is exit, right? So if it is exit, then we can also say something like this to be able to determine the exit code. So basically, we can do something like this: exit code. Um, then we can say, okay, um, what can we say? Let's check if the second input, right? Um, let's check if we have a second input, right? So check if we have a second input, right? If so, I use this and say, okay, if it is true, then convert that second input into a number, right? Using our toy, basically, and if not, um, return what's the last exit code. Last exit code. So remember, the last exit code I used was 0, right? So boom, could do something like this. Okay, so we can also say, all right, cool. So free something like free line, free the input copy, um, free token, right? And use the exit, right? Use the exit code, right? So do something like this. Boom. All right, cool. So let's see if it works now. So let's compile this. Uh, all right, no errors, but then let's see if it works. All right, good, it works. So let's also see like if we can use. All right, so boom, it also works. Let's try something else. Mm, all right, so let me see. Um, so it basically exits with the particular exit code designated like in this exit code, right? So what else? So that's for exit, right? So let me see. So what's the next task? Implement env built-in that prints current environment. So I think env works already. directly with, so let's say, separate my let's say I have my shell. I might do something like this. And right, let me see. Um, okay, let me exit this. So I think the env works, but it doesn't work properly. Alright, so um let me say something like this. Boom, come here. Let me do something like this. And if strcmp. Alright. So we're gonna use a for loop. We're gonna use a for loop and say something like int j is equals to 0. Um, then we could say environ. Let's use environ. So environ j equals null, right? Then we increment j, right? So we could do this. Say print format specifier for string. Right, next line. Environ j, right? One. Then you could do something like this. Free the line, free the inputs, copy, free the token, then continue to the beginning of the program. Alright, so let's see if that works. Boom. Alright, so so that like we could have an env, then move to like another line, right? So okay. What's the expected what? Alright, so I know where the error is coming from, right? This was meant to be a semicolon, not. Alright, boom. So do this. Alright, so it works. So clear shell. Alright, so and alright, so if we were to zoom, alright, so this one works quite better. Alright, so if we were to say clear here now, it works. Then we were to say clear again and again. Alright, so let me zoom out a little bit. Env, zoom in a little bit. So the yeah, let me see. Let's zoom in a little bit. Then clear. Alright, so exit the program. Boom. It works much better like this. That's that. So what's the next condition? Right. Um implement env that prints current environment. write your own getline function. So I want to first finish. Okay, so let's do something like setenv on setenv and implement a built-in CD first before doing like a getline function. So because like um, these ones are more in tandem like with the above objectives, right? So uh, we could read like the manual for setenv and unsetenv. So yeah. So if you want to grasp how to use Setenv and Unsetenv and getenv, use man3 Setenv and man3 Unsetenv, right? So let's take for instance, let's clear this, then zoom in a little because I think the description is quite broad. I'm not sure. Man3 Setenv, right? Okay, so the name setenv included in stdlib, right? So it has these parameters: name, value, and override. So so the setenv function adds the variable name to the environment uh, with value if name does not already exist. So and if name exists, if you put like an override of one, then the name is overwritten. And also the same thing for uncertain. So it returns a value of -1 on error. So let's quit this right here and show you an example of what setenv is. So if you say, let's say printf, right? So it gives all the environment variables, right? So and usually the last environment variable is old pwd, right? So um but then clear and say something like let's say certain let's say Jonas, something like that. All right, so okay, the certain is not found here. Boom. um don't worry, we can define it ourselves. So do this. Okay, so for the setting, right, we want there to be like a name and a value, right? So that means like we're checking for um what's it called? The first index, the second, the zeroth index, the first index, and the second index. That is the first value, the second value, and the third value. So basically, you have to do something like this: strcmp, say tokens. So you check if the first value is Setenv, right? Check if it is Setenv. Then you also check if the second input, that is like the arguments to the command, if they exist. So if they are true, boom. So no, right. So boom. Then say like as a logic, right? Say this is the condition if if the first the token in the zeroth index is set f, right? And there is a first index and there's a second index, right? Because what happens is that like setenv requires two arguments, right? It requires the name and it requires the value. So if these are null, then setenv won't be able to work, right? So let's just put it like this. So say let me zoom this out a little. Expand so you can see. Alright, so basically here you have Setenv and you can do something like this. If Setenv, say tokens 0, right? No, token, that's like the second token, then tokens, so, right. So for me, like I'll be giving it an overwrite of 0 because I don't really want to tamper like with the environment variable, right? Um I want to make sure like I'm only adding things that don't exist there anymore. So if I was to tamper with, if I wanted it to be that like I could edit like any environment variable there, then I would use like an override of 1. But here like I'm not putting any override. Um so if it doesn't work, that is like it throws like a negative value, and print an error, say unable to set and you can use a backslash anyways. So but then like free align, free um the input copy, free a token, continue to the beginning of the program. Alright, so I'll still say this GCC shell. Alright, so if I was to say set and say flowers as this, so flowers being the name of the environment variable and as is being the value of the environment variable, right? So if I was to say something like um env here, right? So let's go down to see if that. All right, good. So it gives me the environment variable basically. So we have flowers as the name, then we have Aziz as the value. So let's let's zoom out. And what next? Um so let's check like if like we've been using the command properly, we've been using the program properly and using memory properly, allocating and deallocating memory properly. So let's do something like var grind shell. All right, so let's say ls exit. All right, um, okay, 12, 9 allocations, 8 frees. That means I'm not freeing something, right? So um let me go back and check what I'm not freeing, right? So okay, I think I know what I'm not freeing. So let me zoom this in a little. So after this I want to free memory for cmd path, right? So boom. So if I was to do this, I think it should run properly on the next one. So let's say so let's call val grind again this time. So let's say val grind shell, right, ls exit, right, 9 allocation, 9 freeze. So it works properly now. Let's use other commands to test it out too. So let's say something like uh what else can I use? Say mkdir, uh, okay, mkdir change, right? Say ls l, right? Say what characteristics have we built into the program? What objectives have we met? Say something like say okay, let's say Setenv, let's say Setenv, okay, cool. Then let's say exit. Let's see what. Okay, no, I wanted to run this with val grind. Val grind. Let's cancel this. Val grind shell ls lsl mkdir new do something like Setenv let's say let's say Linux app. All right, so if I was to say exit, then Valgrind will give me the values. Okay, so good. We have 26 allocations, then we have 26 frees. So there are no memory leaks and there are no detected errors in the program, so it works fine. All right, boom. So where and let's remove this new, then remove this change, right? So let's try and print env to see if like those things I set as environment exist, if they don't exist anymore. So that's good. All right, that's good. So that's that for setenv. Then let's say we do something like for Unsetenv, right? So say strcmp tokens zero check if it is equals to onset and right, and also check if just the first token is true. So that's like the first argument to the command. No, it's behaving like this. So if str cmp tokens, the first one, compare it to onset and it's it executes, right? And as an argument to it if it exists. So say if Unsetenv is a negative, right? Print an error. Say or most probably like if if it returns an error, then the variable doesn't exist. Say env variable doesn't exist, right? So next line, boom, boom. So after this, free line, free the input, free the token, and continue to the beginning of the program, boom. So compile. So um, let's do something like Setenv, all of this, then close this down, zoom this out a little bit and say env, right? So obviously it gives us the value, right? So clear, right? So then say unset env for us, right? So then print env, right? So then the environment variable disappears, so it works. Then clear this, zoom out, exit the program. All right, good, it works. It's too big. Then okay, cool, that works. So we've been able to achieve the objective for handle path, exit, env, set env, and unset env. So the next one is cd. So basically let's do something like this. Okay, so say so cd basically like changes, helps you to change your directory. You know how, say you're here now, um you could go to a new directory. Let's say I make, let's say ls mkdir new directory, and you could cd change directory into a new directory, right? Yeah, so cd helps you do that. And it uses chdr which is defined within the UniSTD, uh, basically the POSIX API in the UniSTD header. So if I was to go back, so basically, and also let's say something like this. So here you see different arguments to CD. So here is moving to a new directory. Here it is moving to um, the previous directory, which is was coming from, right? So yeah. Now if I was to say something like this, let me remove this directory. Okay, and I was to run my shell. If I was to say something like mkdir new directory, it works. as a list it works. If I was to do something like this, command not found. So uh, that sucks, right? So um, all I want to do is be able to put in cd as like a valid command into our shell, right? So exit the code, go to shell, boom, right? So let's do this. All right, so if the command, that's the first command, is cd, right? Um, I want to be able to do something like so you can, because also we want to be able to do something like this. So say, take for instance now you say cd, right? It takes you directly to the home directory, right? So I we don't just want it to be that like we have to, you don't have to necessarily supply like an argument to a cd command. So basically we want to also account for that. All right, so I'll be accounting for that in my code and do some like, let's remove this new directory here. And do something like this. So the only thing you need for cd to run is just cd alone. All right, so that's change directory. So we can do something like cd args. All right, we can say, okay, you know what, like if another, like if an argument exists to cd, right, um return the argument, right, and if it doesn't, return get home. All right, so home is basically the home directory. So I'll give you an instance of what I'm talking about here. So if we were to, let me zoom this and say something like env. All right, so home always shows the home directory, right? So and that's what we are going after by using getenv. So I also do this, boom, say something like mhm. So so if cdx is true, right, and let's say strcmp, right, say cdx, let me check for, let's say this, right, compare. So that's like going to um the directory, like up the directory line, right? So I'll also do something like this. Okay, good. All right, so um I'll do something like, say cd pwd, that's like the current working directory. you get current working directory. So current working directory is usually defined by pwd, right? So also get the old working directory. So pwd get them so use old pwd, right? Boom. Okay. So then you can do something like this. Say if ch dir, right? Mm, do something like this cd, because we don't want to. Yeah. All right. Cool. I want to be very specific. Boom. So old, old pwd or something like this. Uh, that's better. All right. So change to the old working directory. So if like it returns an error, print an error message, unable to change directory, or something like directory. It gives an error anyways. So but then like that's just my extra thing I'm doing right there. So now what you want to do is you want to use your setenv, right, to change afterwards. After this happens, you want to use your you want to use your setenv to change the current working directory, right, to the old working directory. So do something like this. Boom. Then you use an overwrite of one so that you can overwrite it in the path. Right. So you use setenv. Then you say old pwd. You change it to what cd pwd. So use an override of one. Boom. So basically what this line of code does is that like it collects the value of the current working directory and stores it in cd pwd, right? It corrects the value of the old working directory and stores it here. So whenever like you are meeting a condition of like you use like this you use you use um you use an hyphen, right? As like an argument to cd. So basically what it does is like it takes you to like the previous um directory where you were coming from, right? So you can this pwd becomes here, right? It becomes here, right? So that means like after we've changed our directory, we are setting our pwd to like this old one that we just we just changed into. Then we are setting our old pwd, right, to where like we were before. So yeah, that makes sense. All right, so obviously we want to free the line, free our input. Uh, boom. So mm, then also free the token and continue to the beginning of the program. Right. So obviously because we don't want it to get to execv so it doesn't return an error. Right. So now if we run our program, let's see if it works. Boom. So let's do something like this now. if I was to say cd this, let me say, okay, let me say mkdir uh, new directory, right? So if I was to say cd new directory, it works now, right? So okay, it doesn't work yet because like I've not allocated like I've not allocated a logic. I've not assigned a logic for that, but let me do that. Like let me say one um so as if, so say chdir, right? If all right, so what did we pass as the uh okay tokens, the second token basically. All right, so and okay, say cd args, right? Done. Print error, enable change directory. Done. So I think with this it should work perfectly. Uh, all right, good. So um, let's say I run the program. Boom. So I say cd new directory. Right. All right. So listing it, that means like I'm in the new directory now because like there are no files inside. So if I now say cd, like, so then I think let's say I think this should work perfectly now. So let's say I do something like cd new directory, right? And I go backwards, right? So already like it is stored in the environment variable. Then I run the program, boom, and I say cd new directory, right? So if I list it, like it doesn't show it doesn't show any files because we are in the new directory and like there are no files like defined within it. So if I say cd this, um, yeah, it works. So this, I say cd this, takes me to the new directory. If I say cd this, takes me to where we were before. So then if I was to just say cd alone, it takes me to my home directory, right? So if I was to minimize this and print, say print n, um, so basically, uh, where's pwd? Pwd is always higher. All right, so Um, cool. So let's do this. Boom. So that works. And the last objective is to basically write your own getline function. Hmm. So I think the code is mostly complete. Yeah, I think it's fairly okay and really simple. And we're able to do this in how many lines of code? Okay, 248. So not much at all. So okay, trailing lines. All right, so 248 lines of code, not too much. So yeah, this is my expression of like a simple shell basically. So on to the next stuff, creating a getline function. If we want to create a getline function, then we'll probably do something like this. Getline, all right. So okay. Um, the name, getline, the synopsis. Okay, so you have to include stdio. Um, then okay, this is the prototype, right? So the function type is a signed integer, right? So the first parameter is a double pointer, right? And the second one, so basically, this is going to be like what's it called? There's a way C works where you could use something like this to have access over the value of like a line, because what it is that like it can take the address of a pointer variable. That is, it can take the address of a string. Then you can use this to manipulate the value of that string, right? So also the same for this. It can take the address of an integer, and you can use this to manipulate the value of the integer. So file stream is basically you can pass in you can pass in std in so that it takes data from standard input, right? So um okay, this is description, reads an entire line from stream, correct, storing the address of the buffer containing the text into, all right, good. The buffer is not terminated, includes the new line character if one was found, all right. So um and so on and so forth. On success, Getlim return the number of characters read, right? So including the delimiter character, but not including terminating null bytes, right? So this value can be used to handle embedded null bytes in the line read. So both functions return -1 on failure to read. Okay, so errors and like example of use. Let's see. Okay, get line, boom, something like this, right? So this is how to use. Um, this is how to use a get line function. So um, basically, come here. Let's clear this. Say let's say get line. Let's see. Right. So we include stdio. I mean, include standard library. Okay. Cool. So now we can have something like this. Since it is returning a signed integer, right? So we're gonna do s size c. Then we can say get line, right? So because obviously we there's already a get line in the standard API header. So we don't want to we don't want to define another one of the same type. So we want to signify using this underscore in front of it to differentiate it from the actual get line in um, the stdio uh, what's it called, um, header file. So basically we can do something like this, line pointer. All right. So then the second argument is size. Okay. So yeah, then the last one is file stream. All right. So okay, we can still prototype it since we want to use it. We might want to use it later on. So say something like this. Line pointer. Do something like this. Let's say file stream. Okay. So I think the first order of business is to check whether any values are actually passed to the as arguments to the function, right? So check let's check this equals to null, or n equals to null, or stream equals to null. So you could see some people might find this confusing, like why is n equals to null? So basically, this is a pointer to an integer, right? Not an integer variable itself. So basically, it stores the address of an integer variable. So if we were to call this getLine function, basically be using ampersand len and ampersand line. So to store the address of the integer variable and the string variable into these parameters, pass them as arguments basically. So and like it is described in the manual, if there's an error, it return -1. Boom. Right. So you could also check and see if the line pointer is null, or what's it called, and you can do and any of the above. And let's say this is 0, right? So it's most likely you're going to initialize your len with 0. So basically you can say that means you are determining like the number of the size of the input basically. So let's say 128, let's say the size is 128, then you can, what's it called, assign memory to this using this malloc. um yeah, so boom, right? So you can also check if it is defined properly, right? So if it isn't, then no. uh, right, so return -1. So boom, there that goes. Then another thing you want to do is you want to basically define the size of. Alright, so you want to also create, say, position to be able to look through your line pointer, right? So you want to create this. So it says something like this. Boom. Um, okay. Then we say f gets so string. So while it is not equals to end of file, boom. Within the loop, we check the position plus one is greater than or equal to. Alright, so this basically this basically means that, like, let's say you've looked through what's it called, the input, right, and it's greater than this designated number, right? So and the designated number is what, 128, right? So you can give it like a new size. So say something like this, new size. Then you can do something like this. Uh, then also you can define a new pointer basically. Um, so you reallocate using the former pointer, which is line pointer. Um, then you use the new size to reallocate. So you say what if the new pointer is null, then you return a negative one. So um, now also you can basically do this. Let's say hmm, line pointer would be equals to the new pointer, um, semicolon, right? So and also n will be equals to what's the name size, right? So boom, there you have that. Then outside the loop, you can do something like this. So basically, you're looping through looping through each index, right, of the line pointer. So yeah, giving it so you're typecasting C basically. So then you can say this. Uh, uh, so, uh, so what this basically does is like, okay, it checks if the position, that is, since you are incrementing through since you are incrementing through the input, right, and you already have like a defined memory for the line pointer, right? So and so you're using this right here, so position plus plus, right? So once it gets to a point where it passes 128, right, that means 128 plus plus 1, or let's say it's going to be 127 in this case. So 127 plus 1 is 128. So greater than or equals to, that means 128 is equals to 128. So obviously we need more space. So then you double the space, right? You reallocate a new size for the memory. You return a negative one it fails to um if it fails to reallocate the memory. Then also you update the line pointer basically. So I think let me say this. It's an error right here. Boom. Right. So um okay. Okay. Yeah. think um, this makes a lot of sense. All right, so I'm gonna come which is outside of the while loop. Basically, I'll do this say position 0 and C is at the end of file. Right, so um, I want to basically return -1. So basically, what this is saying is like if no input was passed, right, and like if you just triggered like or or rather like if like an end of file was like triggered, right, so like return like a -1, right, so mm, so um do this thing. Basically we are not terminating the last index, right, so then return. So basically is a typecast of uh, the number of lines that have been read. So get this from top right here. So um, position starts at 0. In C, it gets data from file stream. Um, then so far as it is not equals to end of file, you loop through, right, and you assign it the data, right, so and if what the data is next line, you get out of the while loop, right, and um if the position is 0 and C is end of file, you return -1. So mm, and you not terminate the line pointer, then um you return like the position, right? So that is like the amount of characters that have been read. So if you come here, how to use this function, you use it like a regular getline function. So let's say something like this. In the main, so boom, I don't want to create any trailing spaces. Okay, so say something like line, right? Define, give it initial value of null, right, then say something like size t, all right, so remember in our function here, the type that will be able to go and fit and pass like as an argument here is a string, and the type that will be able to go into here, or no, the address of a string variable rather, and the type that will be able to go into here is the address of an integer variable. So basically you come here uh, and you say something like say len is equals to 0. um, so you do this, um, let's say okay, let's define so can do nread. So basically this is a signed integer, right, in case like it returns -1, um then we can basically say prompt to the user, say something like uh, so basically you can come here and you say something like this. Give an input. So then we do something like read getline, right? So ampersand line, ampersand len, std in. All right, good. So we can do something like if rather than making it just a statement, we're gonna say if it returns a -1, print an error. Um, so don't read line. All right, so do something like this. All right, so let's say get line, get line. All right. Um, all right. So I think I used the wrong function. Let me see. Let me see. Uh, all right. Cool. Uh, all right. Cool. Works. All right. So run it. Give an input. Whatever. Right. Um. But then let's check. Um. All right. Good. So it means it can read line. So basically, then we can do something like this. Say, boom, send us. Um, next line. So then we can pass line here. So try to do this again. Get line, get line. All right. So say something like get line. All right. Blah blah blah. All right. Good. So